tyFlow basics, the set target operator explained in detail. Alright, so taking a look at the set target properties operator here, we can see that this is the current set of rollouts that exist. So if we're looking at the main rollout when you first put a set target operator in a flow, it comes up with by value, and so this is the main rollout as it's first seen, and these are your target options. Depending on what target options you have here is going to depend on what other rollouts appear. So for example, by value you'll have this rollout, right? And if you're at random or proximity, you're going to get these rollouts. So if you essentially follow the diagram, you can see all the different options that are available as of the current tyFlow for the set target operator, and it's going to take us a little tiny bit of time to explain all this in detail. Alright, so I've set up this test flow here so we can start talking about the parameters in the set target op. Before we do that, let's just go over this flow. Essentially we have 3 events and they're pretty well identical. The main difference being that the frame at which they're starting on, and that has to do with particle ID creation order, and that's important, and we'll talk about that in a second. Other than that, it's fairly typical. We're going to birth 10 particles on frame 1, we're going to put them on an icon, and we're going to use this, talk about this in a second, about initializing the values. But this set target op here in event 1, that's just totally created with its default values, and the find target op in each flow is just so we can actually see particles moving to their targets, because there's no direction arrow over here, so you don't know without some movement which is the actual target and which is the source. So by putting a find target in there, we can make a move and know that. And then also important, I've put these display ops in each flow or each event, and that's just so we can see the ID of each particle and also what value is currently in the target file for that particle. So I'm going to delete that, and then we're going to talk about evaluation priority and frame start frame order. I'll try and explain this section as fast as I can. We need to talk about particle IDs. Each particle is given a unique number. That number is a float number. Remember from our earlier discussion, float are decimal numbers. Every particle in the system must have a unique ID. So if we have 1 to 10,000 particles, we have 1 to 10,000 unique IDs. Those IDs are given out in the order of the event creation. So if we had our example here, and let's say that everything is the same, right? So this would be 0 and 1, this would be 0 and 1, and this would be 0 and 1. So all of them start at the same frame and all of them have the same evaluation. Then the order of the particle IDs being given out would be in that order. So for example, ID 1 to 10, 11 to 14, and 15 to 20, so to speak, as an example. If we delete that, if we mess with the frame order, the start frame order on the birth, that's essentially the same as changing the evaluation priority. So in this instance, the earliest start frames would get their particle IDs given out first in the order of the events, and then because this is a later start frame, then this would end up being the third set of IDs given out, and that's what we're showing over here. If you can see, ID 0 is an ID, so 0 to 4, and then 5 to 8, and then 9 to 18. So that's the order it was given in. Now you do need to know about this start frame, and you do need to know about this evaluation priority. And they both accomplish the same thing. So these set target operator here needs to be evaluated after all the other events, so that it can set targets to all the particles in the flow. In other words, you're either going to have to change the priority to be later than the other events, or change the start frame to be later than the other events, so that when the set target operator is initiated, all the particles exist for them to give out IDs. Now, for example, if I set this frame number here to be 0, first of all, we can see that the order the particles were created in totally changed. If you look over here, alright, this is no longer the highest number. This is now the earliest number, and they're in exactly this order, that from 1 to 19 or whatever it is, right? And the other thing you'll notice is right now it doesn't matter because we got by value, and it's 0, so every single particle is targeting particle 0. But if I was to go in here to set target and say make it random, alright, now we can see that there's no targets been set here because of the evaluation order. If I now go back in here and change this to be correct either by frame or by evaluation priority, now you can see that there are targets set in all events. Just to be for completeness, right, the evaluation priority, you click this title bar. If it doesn't show up, like it's not showing up here, just click out here and then click there, and you'll get this evaluation priority. And right now you can see all three are set to 1. If I wanted this birth to be at frame 0, then I would just change this evaluation to be 2, and I would have achieved the same thing, and make sure that my custom priority, my set target operator is initiated after all the other events. Alright, putting the set target operator back to its default values, alright, like as if we just inserted it. First thing we notice is that all three events are targeting a particle right here, and that particle ID happens to be 0, alright? So what does that mean? Because we haven't actually set a target yet, we've just dropped an operator in with its default values. Now we can see that we're doing it by value, and the value is 0. But the target file is also initialized, right? And it's initialized to 0. It has to be initialized to something. So the target file, if we want to control this and not just have, particles targeted without us setting that target, we could do something like initializing the target file. So if we come in here and notice what I've done here, I've set -1 right here, and I'm putting that value in the target file, right? So because I'm saying by value, -1 is not a valid particle ID. So that means that you'll prevent accidental targeting of particles because you're setting it to a non-valid ID. So if we do that for all three events and we look carefully, we can now see that the target for all the particles is -1, and all the lines disappeared. Now there's this one odd particle here that's at 0, and that's because if we turn off the set target operator, because that was initiated, right, you can see that now all of the particles in the system have a negative value. So now it'll only be targeting whatever we decide to target it. And just be aware of that whole thing of defaults and targeting that you may not have planned for. So if we now go back to the set target operator and we look here, and you can see that it's set to 0, so that's why we have one particle targeting particle 0, and if we move our time slider, you'll see that it'll move to that target, right? Now, why is only one being targeted? Because right here we've said prevent duplicate assignments. So now, if we allow duplicate assignments, all our particles over here are targeting particle 0. Now, that seems to be a lot of time spent just talking about particle IDs, timing, and default values, but it's a necessary concept we need to understand. And so I hope I didn't confuse you. Let's start talking about all the parameters and what they do. I've rearranged the tyFlow workspace here so we can see multiple rollouts, and I've also messed around with this first event by changing the set target operator and adding an additional one. If we remember earlier, we initialized our particles, the target file, to -1 so that we didn't have a default value of 0. And on these two set target operators, what they're going to do on an individual basis is, on the first one here, we're only going to set any particles 15 or greater to a target of 2 here. And on the second one, when we enable it, we're going to set all of them to 0. Now, that's for two purposes. A, we're looking at this by value section of the rollout, and we're also going to look at this only set target if current target is invalid and what that means. Alright, let's clear this stuff up. By value, what does this mean? Well, it means that we're going to put a value into the target file that we set. Alright, and that value is going to be the value that is put in this section of the rollout, and that will be put into a file. In this instance, the default name is the target file, right? It could be any name you want, but the default is the target file. So later on, the set target operator will reference that value in the file. Let's tackle this option here and what it means. So let's delete all this stuff on screen and go back to our flow here. And if we look here at this operator, the first set target, you can see that I've set a filter. Any particle ID greater than or equal to 15, set a static target of 2. And we can see how that worked in real life over here. We can see that any particle IDs I have that are greater than 15 have a target of 2 in their target as their target, right? And you can see that the other particles in that event still have the initialized negative number. So, and that means a non-valid target. So now if we move on to our second set target here and enable it and look at its parameters, we're setting a target by value here into the target file, and the value is 0. And we can now see that all of our particles in this event targeted 0, which is a correct action. If we enable this, you can see now we have the original particles that had a valid target, right? So keep their target, and the ones that had an invalid number now target the new ID. So that's what this only set target if current target is invalid option does. And just to refresh that, delete this for a second so you can see, and we turn this on and off. See, valid, valid, valid. Alright? Not valid, not valid, not valid, not valid. The negative number. So when we now enable this thing here, you can see how the ones with the red underline that originally had a non-valid target are the only ones where the target gets updated. So I hope that explained that little option. Random here is you targeting or putting a value into the target file that's in the range of minimum to maximum. And because it's random, it could be any value in there. So if we look over here at our example file, we see that some are set to target values that are much higher than anything we've got in our flow, because we only have 19 particles in total. So it is targeting particle IDs from 0 to 100, but we only have particle IDs going from 0 to 18. So if we want to refine that value, we could say do something like go down to say 25, and we'll see more targets being set, and that they're more realistic numbers closer to our ID range. So randomly it's going to target IDs and put them in the target file between this minimum value and maximum value. Birth ID. Okay, so now we're going to target by birth ID, and if we enable this, right now it's 0 and 0. So let's start with this offset. If I set that to 2, what that means is target particles whose offset is 2 from my own ID. So if we look here at particle ID 10 is now targeting 12. Particle ID 14 is targeting 16, etc. So it's an offset to the internal ID. So if we follow that animation through so we can see it more clearly, you can see that each particle is now targeting an ID that is an offset of 2 to itself. And erase that. And now if we want to do this event offset here, alright, so we're going to offset it by 1 event. So now it's essentially going to look external to whatever event number this is, and this is event number 1. So if we're offsetting it, we're looking at event offset 2 or greater. So I don't have any particle that's offset by 2 because these are the larger numbers. So if I put something like minus 15 in here so that it's looking for lower numbers, right, you can see that with the event offset, alright, you know, 11 minus 15 is targeting 6, right, etc. And you can see that over here. And if we change that offset so there is no offset, you can now see, you know, how that works as far as the offset changes what event it starts looking at for those IDs. Custom float here. We've kind of talked about this already, but let's have a quick look at it. Let's say I go in here and make a new custom properties file, right? And we're going to do it by value, alright, here. And we're going to put a value in here that we want it to target. So let's make it 7, right? So I'm now going to enter 7 here, and I'm going to make a custom file called target 7, right? And so now we have two target files now, one to default and one called target 7. So we've saved 7 in target 7. So now when we go down here back to our operator and we do a custom float and we do it by that file, we've essentially set a target based on a secondary target file, and then the offset would be the same, right? If you do 1 as an offset, see whatever was in that target 7 file, because offset of 1, now it's targeting 8 and 9, etc., 10, 11, etc., etc. So that explains all of the operators in the by value option. Let's finish off this by value by talking about the last 3 items here: the link and move to targets, and this seed. The seed will cover first because we've already covered it. So right, any kind of randomness in a flow, right, any kind of random parts of a flow, by changing the seed you change that randomness. So for example, if we had forces, speed, slow, whatever, any of those that have a slight randomness to them, changing the seed just changes the look of the flow slightly. And there's lots of seeds in there. So the move to target, right, so as soon as the target is set and has a valid target, it'll immediately move the particle to the target. So if we click that, you can see the particles from here immediately move to the target instantaneously. Right, so there's no animation, there's no kind of easiness in of it. It's instantaneous. Now there is a move to target op, right, that we're going to talk about as well, because it's kind of part of this, and that just gives you more options on the timing and everything like that. The link to target, we're going to have to set something up, but it links the particles, the source particles, to their target particle. Think of it like a mechanical arm. So if the target particle was kind of mechanically connected, so something if this particle 7 was doing something, and so if we go into event 3 here, which is where particle 7 is, right, and we say added a speed operator, and let's say we'll do the timing at frame 20 to the end, and when we look at that in action, you see the particles are starting to move on frame 20 there, and rather than do some sort of random, let's do Z, and we'll give it 3 here. Alright, so now we can see that from frame 20 they're starting to move. Now you can see right now we don't have link to target, so the yellow particles are constantly trying to get to the moving particle 7. Now if we go back here and enable the link to target, now imagine that mechanical arm I said, and now when we see the movement, you can see it's like they move with the particle, but almost like they're mechanically connected. So now we've covered all of the options and operators in this by value rollout here, right? We've covered all of this, and now it's really time to move on here and see what the random one looks like. So with random selected here now, we have this new rollout, and it's titled target filters, right? So that kind of gives you a hint of most of what it's about. Now I think this portion of the rollout is fairly explanatory, self-explanatory, right? We kind of have all events, which would be, you know, all 3 of these, or this event only, where the set target operator is, which would be this one over here, or exclude this event, which would be everything except this one. So in this case it would be these 2, right? And you can see that if we say this event only, you can see now that our set target event is only targeting particles within itself and random particles. Right? If we say exclude this event and just approve the movement here, right, you can see that our particles in the yellow event are now targeting anything but particles inside it, so or only external events to itself, and randomly targeting those particles. So with that in mind, let's skip this family for a second and then move on to the particle groups here. So we'll talk about these simulation groups here, and for that I will load another file. Alright, I'm just going to load another file here for a minute. And I've preset up this configuration here. Alright, so this is a fairly simple flow, and it's just for showing how particle groups work. So I've added a couple of extra events so that we have more targets. It's still the same principle. This is still event 1, and this is kind of our source event here, and we're going to target other particles based on the groups. So, you know, if you look here, I've indicated what each group is set to here in my particle group, so we can easily see that, and this one here obviously is set to 10. So what's going to happen here when we look at this event based on groups? We got set target, and we were at random, and the target filter now is by groups. So what we're saying here is find random particles in all events, but limit what you find to group 1, right? Because we've set group 1, and we've put our particle here in group 10. We can see the group numbers there. So when we animate through, you can see that it's only targeting group 1, right? And once those particles reach group 1, you can see some of them are starting to turn this orangey color, which means they found their target. So now this this branch out, or this connection is being made, and they're flowing into this event. And when we look at what we did there, we said in find target here, set target, we now set particles to look for group 2 only, still in all events, but now we're telling the particles only to be applicable to group 2. So our find target is going to be limited to looking for particles in group 2. So now we kind of have this event, and it carries on, and then the same thing happens down here. Once the particles find their target, then we follow this branch of the event. Alright, and finally what we've said down here is go to groups 2, 3, and 4. So now once our particles reach their targets here, they're going to randomly divide up and search for targets in group 3 and 4. So you can see the power of how to use groups in this set target and random operation. And if we play the animation, we kind of get this thing where the particles start here and follow along to each of their targets. I hope that kind of explained the group thing. Export groups work in conjunction with the export operator, and it's just a way of limiting what particles are exported, and is beyond the scope of this tutorial. So I think the best way to explain this section here is with this visual. So if we kind of imagine that we have events and we've assigned these groups to each one of these events, right? So, you know, saying this would be event 1 or whatever, right? Event 2, event 3, whatever we want them to be, and say event 4, and these are the groups we've assigned to those events. Depending on what we had set in our target operator here, set target, depending on what target groups we had set in those, for example, looking at your target filters and what you put here, and then based on what choice you make there, right, this would be kind of the result depending on which setting you have. So I think just absorb the visual and you get the idea. But for example, if this set target is set to 1, 2, then either 1 or 2 will overlap. There's none equal because there's no other one that's set to 1 and 2. Not equal is not equal to whatever it's been set to. So this has been set to 1, 2, which means that you would not equal would end up targeting those. So I think if you kind of just paused and took a quick look at the graphic, you would get the idea of how those options affect particle targeting. Clustering is really used with the cluster type operator and those kind of operations and the files created from them, and is beyond the scope of this tutorial. So having said that, let's move on to raycasting. Okay, so I've loaded this file to discuss the raycasting option here, and it's fairly simple, but while we're at it, we're also going to talk about this move to target. Remember earlier I said that with this particular quick and dirty move to target option, it's instantaneous, it's like 1 frame, alright? And I don't really see a purpose for that. So rather than use that, you have this option to use the move to target operator, which is essentially an expanded version of this move to target, and it just gives you more options, like the interpolation that we all love to slow things down and take much longer. So now that when we animate, you can see it's taking much longer to reach the target. So just keep that in mind about using the move to target. Now when we go back to raycasting here, and basically our flow is this: we've got our source flow where the particle is coming from and heading to the target, and this is the target over here. So if we have an object here which is essentially an obstacle, right, and we've selected it in here for the raycast object and added it to it, like we can just remove this right now, and it's just as simple as add selected, and we've added it to the raycast. Now if we say no raycasting, this object won't have any impact on the animation. If we say rays must hit, if I kind of move this animation along halfway where we knew it would have been, if I now move this box in the line of target, and now the ray is going to hit, which essentially allows the particle to try and reach the target. And the opposite would be rays must not hit. So now if there was a obstacle in the way, it will not fire that particle and send it to its target. So for example, if you were shooting a gun through a bunch of trees and you didn't want it to fire if there was trees in the way, this would be kind of a sample of that. So that's pretty well raycasting, and a quick and dirty talk about this move to target operator. I mean, now what's left here in this part of the operator is talking about the angle part of this rollout. Filter by angle, I've got this little project I've set up so we can display it. So right now this is our source, and we've got 8 particles here on some icons. I've just hidden the icons so that I can birth one particle at the center of each icon for the purposes of this test. So we're targeting random targets in all events except for the one we're in, and we're going to do this filter by angle. So you can see that without it, all the targets are active and our particles travel to all the targets, sorry. And if we filter by angle, parallel means straight up and down, so it's only going to find targets that are perfectly parallel with it. Perpendicular is across, and obviously this one here isn't quite perpendicular, so if we just increase this threshold ever so slightly, you'll see that it was not quite lined up, but so that also gives you an idea of how this angle threshold works. The higher we increase the angle, the more we increase the angle, the more targets we're going to find within the limits, and that works in both directions. So that pretty well explains everything here, and now it's time to move on to by proximity. Alright, we're in this by proximity section of the set target op. I don't know if this is a bug or not. I've just asked Tyson about it. We'll wait and see what happens, but as you can see here, it appears that by preventing duplicate assignments doesn't seem to work. We'll find out what that is about. The target filters thing is pretty well the same that we just covered before in random, so we don't need to go through that again. So right now we're looking at this absolute closest. So we got three events here. This is our source and these are our targets, and we've got it set to absolute closest. Right now particle ID 2 is the absolute closest, and you can see that all particles are targeting target 2 even though we have this on. So we'll wait and see what Tyson has to say about that. Even if I turn it off, doesn't matter. Now it doesn't pay any attention to this. This is only if you're in radius mode. So for this absolute closest, it's only relative to what particle is the closest. Now it could be a couple of them. So for example, if we move this one closer, you'll see that we can get a split of particles choosing between the two, but when we have one that's obvious the closest, that's the one that's being targeted. So I think that's a fairly simple explanation for absolute closest, and then we'll look at this radius thing next. Alright, well, within radius is fairly self-explanatory, but we'll just cover it. So with this select within radius, it's the radius you set here. Now right now we're not close enough in this target. It will give you an approximate sense of distance in this scene. So if I was to select this icon here and start to move it towards, as I get within that 80 range, more and more particles will start to attach to their target. So basically, you know, it's pretty simple. When you select within the radius, absolute radius means the distance you're setting for that target to be reached. You know what I mean? So the bigger the number, the more you'll reach. So if I increase this now to say 130, we'll see we have targets being hit all over the place. Now I can't quite figure this little part out here, and I just can't come up with an explanation at this point. On the bias thing here, it's kind of like one is no bias on any of the axes, and if you increase that value, it'll almost be like increasing the sensitivity on. For example, if I increased the Z bias here and made it something like 50 or 20, it would mean that that would kind of take priority over the detection of the others. So you're almost like volume bias or something. You're kind of increasing the sensitivity of the detection to the target, in one of or all of the axes, depending on what you want. So to me that kind of covers most of what's in proximity, and really what we've got kind of left is I think it's children and parent. What have we got left down here? Yeah, parent and siblings. So let's see if we can figure out something there. Alright, we're coming to the end of this tutorial, and we're going to look at this siblings and parent part. And all I've done is create this simple flow so that I could spawn some particles, and I made it a birth object and a sphere, and that way I could just birth 3 child spheres, and we need that so that we have a whole parent, child and siblings thing. And in case you don't know kind of what that means, I've done this great drawing here, and you know, we have mama here, and who gave birth to some children, and children are siblings of each other. So this is the parent, this is the children, and that's how we're going to look at it in relation to this operator. Let me get rid of this for a second. Alright, so the red one here is our parent. So I've kind of created this animation. If we go back to the first frame here, and you can see we've said from siblings, and the first. Now the first child is this one here, so the first child is targeting its 2 siblings, right? If we say random, then there's going to be a random connections between all of the siblings, right? If we say next, well, because this is the first child, the next is going to make the connections from the ones that come after the first child, right? And previous would be kind of, you can see the targeting here, there's no previous to the first child, so that's why its target says -1. And you can see how the targeting works if you look at the custom display data I've set up. So that kind of gives a brief explanation of sibling targeting, and parent would kind of be the opposite. The children are going to target the parent, right? So you can see that the children have all targeted their parent. Now I don't know if this will work, but if we said, you know, move to target, and they're not going to. The reason I didn't move to target is I got my time set to on entry, right? So to circumvent all that, I just put in a time test, say from frame 50, made this move to target operator in here, made the timing continuous, and basically from 50 they'll slowly start to move towards their target now, just so I didn't end on a bad note. You see, there you go. Alright, that's the end of this tutorial. We'll try and do a couple of practical examples in the next one. So this is the end. See ya.